Okay, so we're gonna continue with chapter 2. Last time we met, I gave you an overview. I know it's kind of a lot of information to digest, but there is a lot of information from chapter 2. Chapter 2 is one of the very few chapters for the rest of the semester where we're actually going to cover everything from chapter 2. In chapter 3, chapter 4, there's like sections that we're not going to talk about because it's related to graphical user interfaces, but chapter 2 is one of the few chapters that we cover everything. Like everything in chapter 2 is going to be on the midterm. Okay, so it's kind of a lot of reading. It's kind of a lot of stuff, like information. So I'm going to go and just read a couple of read through the slides and maybe cover like a couple of sections and then give you guys some work to do in class. Okay, so character strings. So a string literal is represented by putting double quotes around the text. To give you some examples, okay, so we use this. Whenever you have a double quote is what we call a string literal, where Java is going to treat those characters as a string. Every character string is an object in Java defined by the string class. Every string literal represents a string object. The print line method in the linking class from chapter 1, we invoked the print line method to print a character string. The system.out object represents the destination, which is the monitor screen, to which we're going to send the output. So here they're just kind of giving you right here, the system.out represents the output console or the monitor, and then print line is a method that gets invoked to actually take whatever data is being passed to it, which inside the double quotes is what we call the string literal, and that's exactly what's being written onto the screen. System.out object provides another service as well. The print method is similar to the print line method, except that it does not advance the next line. Therefore, anything printed after print statement will appear on the same line. So they're giving you the countdown method. So here's an example of what they're talking about. You know, I'll do the exact same example. So I'll just hop over to Notepad++. Dang it, clicked the wrong one. I'm going to make a new example. I'm going to say save as, excuse me. And this is, I think this is my Java 2 folder. I'll call this one print example. All right, so public class print example in public static void main string array arguments. All right, so before we were using things like print line, so everything would be on its own line. So they're giving an example of 1. Okay, 1, 2, 3. All right, so when you compile and run this program, all those prompts are going to be on their own separate line. Oops. All right, so from here, I'm going to run the command Java C, the name of my program, which is print example.java, compiles, and then to run. Okay, wrong one. Shit. All right, so there's the output, right? 1, 2, 3, take off. So if I were to actually, instead of use a print line, just use a print, what's going to happen is it's not going to advance to the next line. So when I compile and run, you can see it's all in the same line, right? 1, 2, 3, take off, right? So that's what the print does. If you want to put everything on different lines, but just have like separate lines of code doing that, you just use print, and you just keep attaching to that one line. So since I use a print line here, the next line after that is going to be on its own separate line. Like if I just copy and paste the one again, save it, hop over here, recompile, run, you can see that this one is now on a separate line, even though it's just print, but the line above it, right, use print line. So just put like a new line character like right after the exclamation mark, so this one started on a different line. Okay, so that's the print. And I just did the example that they used in the book. All right, concatenation, string concatenation operator is the plus sign, is used to open one string, or excuse me, is used to append one string to the end of another. So they're combining peanut butter and jelly. It can be used to append a number to a string. A string literal cannot be broken across two lines in a program. See facts. Okay, so what they're talking about is, we'll just do another example. Oh, shoot. Come over here, new file, save as string. I already have something called string demo, so I'm gonna make one called, this one called string demo 2. All right, so I'm gonna have a string, right? So let's say like F name for first name. Let's say like, see somebody else, I guess. So if I wanted to print the first and the last name, I could do something like this, name, colon, plus F name, and O name. All right, I'm gonna compile, run this, we'll see what it looks like, and then we'll come back and correct anything that we need to correct. Come over here, compile string demo 2. Right. Okay, so I had two strings. Actually, I had three strings technically, right? So this is a string right here, string literal, and this is a string from a variable, but I was actually using a literal to assign that value. So concatenation happened by putting the plus signs, right? And I know, like when we did that quiz, the quiz at the end of last week, there's a lot of people asking like, how do you get a space between the first and the last name? So this is the way it printed out. So I can simply just concatenate in another string literal, but this time the string literal will just be like a blank, right? It just has a space character there. So now when I compile and run, you'll have the space between the first and the last name. And that's string concatenation. So one of the things the book says is if I were to just print something out, a string literal, like really long, it's just like a bunch of stuff like this. Okay. Save this and hop over here, clear my screen, compile, run. All right, so here's the string that I printed out. Okay, now what they're saying is, let's just say it's too long, right? Like I can't, like, I don't want to have to scroll over to see the end of it. What I can do, or well, what some people think they can do, is just press enter right here. If you do that, it's actually a compilation error because Java doesn't see the opening double quote here and a closing double quote here, right? It doesn't like take into account that new line character that you type in there. It's not gonna be able to wrap. So like when you come over here to compile, it's not gonna compile. Okay. So if you wanted to wrap this string because it was too long, then you have to put like double quote here and a plus sign right there, and then hop over here, put double quote there, right? And to say I wanted to break it up again, like maybe like right here, And that's the way that you would wrap a string literal. You would just have to concatenate. You would just break it up into pieces and then concatenate it. Right? And the only problem we're solving was that it was on one line, it was too long, and perhaps like we're like, it's going too far, I have to scroll, right? And you're just trying to avoid having to scroll. But that fixes the problem, so I can actually compile and run. All right, did I just read this, or is it another slide? No, I guess there's 2 slides on it. All right, so string concatenation. The plus operator is used for arithmetic for addition. The function that it performs depends on the type of information on which it operates. If both operands are strings, if one is a string, and one is a number, it performs string concatenation. If both operands are numeric, then it's going to add them. The plus operator is evaluated from left to right, but parentheses can be used to force order. So this is a problem that we ran into. I showed you guys last week, but I'll show you again. So let's just say you have system out print line, and then you just say, let's just say you're trying to put like a number after their first name, right? We'll put 7, okay? All right, so this is the way it looks, right? That's exactly what we expected. You have a string here, you have an integer here, but now let's just say you want to add, I don't know, 100 to that. Oops, 100 to that. You know what's going to happen is it's actually going to concatenate, because the first one's a string. It's going to combine the 7 to the string and then the 100 to the John 7, which is a string, right? It's not going to add them together. So if you actually wanted to force arithmetic here, you would have to use parentheses. Oops. Parentheses to force the 7 and the 100 to be added together. All right, and now you can see that the 100 and the 7 were added together, where before it was just 7 and then a 100 after it. Okay, so depending on what type of data you're working with, this plus sign is either going to concatenate or it's going to actually add. Now they give you the same example in the book. Oh, this is actually something kind of cool. Escape sequences. So what if we wanted to print a quote character? The following line would confuse the compiler because it would be interpreted as the second quote as the ending of the string. System out print line, I said hello to you. The escape sequence is a series of characters that represent a special character. So an escape sequence begins with the backslash, and here they use that to print out I said hello to you. All right, let's do that example. So we'll come over here and copy exactly what they did. Oops. So they tried doing I said hello to you. So this is, yeah. Okay, so when you go to compile, right, the compiler's upset because it's seeing this as the end of a string, right? It's seeing that as one string, and this is another string, and then like some weird variable that you've never declared anywhere, like hanging out between those two, right? So it's like super confused, like it doesn't really know what you're trying to do. So you're getting 3 errors when you just really made one mistake. But if you wanted to include double quotes inside of a string, you would use escape sequence by using the backslash. A backslash, that will tell Java that those aren't the double quote for the end of the string. It's double quote that should go inside of the string literal. So now we come over here and compile. It does compile, and then we run. And there's the output, right, with the double quotes. I said hello to you. There are other escape sequences. There's one for backspace, one for tab, one for the new line. A return carriage, which is kind of an interesting one. I don't see any point in using that one, but it basically takes the cursor to the beginning of the string and like starts overwriting. The backspace will just it's like if you deleted the first character in front of you and started typing. Then if you wanted to do double quote, single quote. Now, in the recent Java, you don't have to actually, if you want to put a single quote, you don't actually have to escape it. In the older versions, you had to. So if I wanted to copy this, and instead of using double quotes, use a single quote, there's two ways to do it now, right? Using single quote inside of a double quote is okay. In older versions of Java, it was not okay, and you actually had to use an escape sequence, right? You see the single quotes there now? You gotta do it like that before. And you get the same result. Okay, let's go over a couple of these though. All right, so let's see. So backspace is kind of weird, but I'm gonna insert right here. I'm just gonna type this is backspace. Okay, so let's look at the result of that. Let me just get rid of that. All right, so what that actually did was it like deleted, like as soon as you did the backspace character escape sequence, it like went back and deleted the character before it, right? You did it again, it deleted that character, did it again and deleted that character. Then when you put more characters in, it kind of just looks like it overwrote those characters, right? So you put these three in here, it went basically deleted these three characters right here. And it started writing test on top of that. I don't know why anybody would use that. I've never had used that ever. The tab is actually one that does get used a lot. So let me do an example of that. This is a tab example. So if you use a tab, instead of putting spaces, it's going to put like those 5 characters, like at least 5 characters in front of each word. All right. So hop over here, clear my screen, compile, right. Right, so it's like tabbing it over. Right, so it's like the space. All right. The next one was the new line. This is actually kind of useful if you want to have new lines, but inside of a string literal, meaning like you want everything to be on a different line. You just slap in those new line escape sequence instead of having to print out, do a bunch of print lines, right? So say I wanted every word on a different line, I can do something like this. This is a new line. Okay, and then where all the spaces are, I'm going to go back and put in the escape sequence for a new line. All right, save it, hop over here, clear my screen, compile, run. You can see that all these words were on a different line because I used the new line escape sequence. Instead of having to like make a system out print line for this, the one for is, and the one for a, the one for new, one for line, I could also have done, just do it like that. Just use the new line escape sequence. All right, we did the double quote, we did the single quote. Oh, the backslash, oh, I skipped this one, the R. Return carriage, that one's kind of interesting too. It kind of works like the backspace, except it goes to the beginning of the line. So I'm gonna just grab what I did here, and I'm gonna paste it right underneath it. And instead of using the /b, I'm going to use /r, just one /r. And when I come over here, clear my screen, compile, run, you can see on this one the test got overwrote this, right? Like you got right here and then you went to the beginning of the line and then you started typing again. All right, you just stayed on the same line, but you just went to the front and then you start entering whatever happened after the return carriage. That's what it does. Okay, backslash, so just say you want to put a backslash inside of a string. Um, but this is a backslash. All right, so let's see what happens if we compile without using. Okay, so it won't even compile because Java thinks that you're trying to create some type of escape sequence, but since we're not actually trying to do that, if you just want to use a backslash just to have a backslash, we have to use 2 backslashes. So now when I come over here to compile, it's happy. I run, and you can see that I have 1 backslash there, even though I use 2 because I'm using an escape sequence to write the backslash. All right, those are escape sequences. You will have to know these for your test. I'm going to have a couple of questions on them. All right, they give you some examples here in the book, and that is it for character strings. Now we're going to talk about variables and assignments. All right, so a variable is a name for a location in memory that holds a value. A variable declaration specifies the variable's name and type of information that it will hold. So here is a declaration. We're saying here is the data type, which is the int, and then here's my variable name, which is a valid Java identifier. Do you guys remember the valid Java identifiers? It could be a letter, a digit, underscore, $sign, but it can't start with a digit, and it can't be a reserved word. Okay, so the variable name is an identifier, but it's just, right, what did I just say? That's the reserved word, excuse me. The variable name is an identifier, right? So we have the data type and then the variable name, and the variable name is an identifier, that a word that we make up. And let's see, so multiple values can be declared like in one line, like the way they did it. So they wanted to have 3 integers, so they just declared them all by saying int, and then they used 3 different variable names. But notice that they used, right, they didn't use a semicolon, right? So whenever we declare a variable, we're pretty much just telling Java we want to reserve this variable name to hold this type of data, and then somewhere in the program we're going to have to actually, I mean, if you want to use that variable name, we're going to have to use it, but we can't use a variable name without actually declaring it. Otherwise you're going to get the cannot find symbol, where that's a really common problem. Let me give you an example of that really quick. So I'm going to call this one variable example. All right, so public class, name of my class, and public static void main string array arguments. Okay, so let's just say I have int num1 and num2. So I declared num1 and num2, so I'm trying to print them out. But when I actually go and compile, I'm going to run into some problems. Okay, so it's upsetting me right now because it's telling me that num1, num2 might not have been initialized. What that actually means is there's no value, there's no data. Right, so let's just say I'm going to initialize them right here. Let's say, okay, well, num1 is equal to 5, and num2, we'll say, is equal to 90. So now when I compile and run, Java's happy. All right, but if I tried to like use a variable that has not been declared, like num3, there's nowhere above do I have a declaration for num3. Now I'm going to get a different kind of error. that's the cannot find symbol. So whenever you see cannot find symbol and it's pointing to some value, that's just Java's way of saying, like, I don't know where this value exists, this variable exists. It doesn't exist. It could be a method name or it could be a variable, but it doesn't exist in Java. That means that you probably did not declare it anywhere. So if you want to actually use that variable, declare that variable, you just come up here and slap it in right here. Or if it's going to hold a different data type, then perhaps you could just come down here and say, okay, well, num3 is going to hold a 7.8. Right, it's a float, and I don't need to initialize it. It's already been initialized. So I'm going to save, clear, compile, and run. Okay. So cannot find symbol just means you never declared it, and it might not have been initialized. Just means you never initialized the values anywhere. Okay. Those are like two really common errors that you'll run into. Let me hop back over here. All right, they're giving me an example of some declarations. A variable can be given initial value in the declaration, so you can give it a value inside of the declaration, or you can just set it later on. It doesn't matter. When a variable is referenced in a program, its current value is used. So they're giving you, all right, whatever. All right, so they're just trying to tell you that here, I print out num1, but if I come down here and modify num1, let's just say, I just say, okay, well, num1 is going to equal to num2 plus 13. Okay, now num1 is going to have a new value, and then wherever I reference that value, that's the value that it's going to use, whatever is stored in num1. So this first line, we're going to use 5. The second line for num1, it's going to be 90 plus 13, which is 103. So I'll come over here, compile, run. You can see that num1 is 103 down here, but up here was 5. Right? That's just what they're trying to explain here in this slide. All right. Constants, that's actually something kind of important to know. If you look at the coding standards, there is a particular way I want you to write your constants. A constant is an identifier that is similar to a variable, except that it holds the same value during the entire existence. As the name implies, it is constant and not a variable. The compiler will issue an error if you try to change the value of a constant. In Java, we use the final modifier to declare a constant. So final, the data type, and the name of the variable. Now, by convention, we give it all caps. All right, that's just the convention that's been adopted for Java to signify that the value is a constant. It doesn't change. Okay, so next slide. Constants are useful for 3 important reasons. First, they give meaning to otherwise unclear variables. For example, max load. We could use 250, but putting it into max load would give us an idea of what the value actually means. Second, they facilitate program maintenance. If a constant is used in multiple places, its value need only to be set in one place. So if it ever changes, you could just go change it one place. Third, they formally establish that the value should not be changed, avoiding inadvertent errors by other programmers. If you make something constant, it can only be assigned a value one time, and that's it. Otherwise, the program will not compile. Okay, so there's many reasons to use a constant if you feel like the value is not going to change inside of a program. So let's just say, let me come over here and make a new example. And I'm going to save this as, I'm going to call this one average. All right, so public class average and public static void main string array arguments. All right, so what I'm going to do is I'm going to find the average of some numbers. So I don't know, say like float 1 is 100, 2 75, and 3 say like 87. Okay, then we have a float variable for average. Right, and then I'm going to say First, I'll print out each value. Pretend that these are test grades. All right, and then average is going to be equal to, we'll say num1 plus num2 plus num3. All right, we're going to sum those together first, and then we are going to divide it by 3. Alright, so I'm going to hop over here to our screen. Oh, thank you. Let's see, oops. Alright, compile and run. Alright, so there's my average for those 3 test grades. Now, this 3 is in this equation. Okay, now that's something that I want to remain constant. Let's just say this is a program that keeps prompting students to enter in their 3 test grades. And there's several places where I'm using this 3, right? Then like the next time I'm asking somebody else to enter a grade for this or that. So I have the same equation done somewhere else. So if you know that you're only going to ask for 3 test grades, you can come up here and make a constant. We'll say final with final modifier. And then the type of data it's going to hold. In this case, it's an integer. The 3 is an integer. I'm going to say num test. Now, by convention, we give it all caps, and we use the underscore to separate words within this. Okay, and I'll just say 3. And now, if I come over here and use that instead, it's going to work just the same. You won't be able to tell any difference. I'll just compile. And I'll run, just dang it, I'll run, and there you go, right? It looks exactly the same. But if I try to come over here and try to modify number of tests, right, that is going to cause a compilation error, right? Because it is I declared it as a constant. So if any other programmer like just came into your program and tried to change that value like somewhere else, and you know that it should be 3, and they try to change it to something else because they didn't know any better, the program will not compile, okay? So declaring by something constant will allow us to keep that value constant throughout the program. All right, primitive data types. All right, this is where there's a lot of information just thrown at you at one time. All right, so there are 8 primitive data types in Java. We have 4 for integers, byte, short, int, long. We have 2 that represent floating point numbers, float and double. One of them that represents a char, and then one that represents a Boolean. Okay, here are the different sizes. I'm not going to make you memorize these sizes, or excuse me, the min and max values, but you should know what the sizes are. They're storage sizes. Right, a byte is 8, short is 16, int is 32, long 64. Float 32, and a double is 64. Characters, there's we have what we call character literals. They're annotated by using the single quote. Okay, you got to make sure you know the difference between a character literal and a string literal. So a character literal can only hold 1 character. So if I wanted to make the char data type, I will assign it to a character literal by just using the single quote. And here they tell you to note the difference between the 2. The characters do come from a character set, right? So a character set in an ordered list of characters, which each character corresponds to a unique number. A character in Java, or excuse me, character variable in Java can store any character in the Unicode character set. In the back of your book, they talk about the Unicode character set. You could also Google it. There are 65,000 different unique characters in the Unicode character set. The first 128 come from the ASCII character set, which is like an American standardized character set. But there's 65,000. Now, you won't be able to use all 65,000 if your computer does not support those international characters, but I can do like a quick example of that really quick. The ASCII character set is older and smaller than the Unicode character set, but it's quite popular. The ASCII characters are a subset of the Unicode character set, including like the capital A's, or capital alphabet, lowercase alphabet, semicolons, like all the punctuation marks we can use, the digits, special symbols, there's carriage return, tab, and all that. Okay, so let me just do a quick example of this. So I'll hop over here, new file, save as char demo. All right, so a char literal is just something like this. I don't know, let's say like char 1. Okay, now you can't give it a double quote because it will be make it a string. So let's just say if I have char 2, I can't give it a double quote and do like a semicolon. If I try to compile and run this program, it will not compile. All right, let's save that. I'm gonna try to compile. All right, didn't compile. It knows that the string literal is trying to be forced into a char. You have to use the single quote, which tells Java it's a char literal, and now I can use the char. Dang it. Lost it. All right, and there you go, right? Real simple. Now, one interesting thing though is that because the characters come from the Unicode character set, you can actually just assign them a number, and then whatever value is at that location is what it's going to be. So for instance, if I was curious to find out what value is stored at, I don't know, 100 in the Unicode character set, I could just assign it the value 100, and it's going to tell me the character that it's going to give me is going to be the character at that location. So I can hop over here, clear my screen, compile, and run, and it's lowercase d, right? If I wanted to know what was that 0, which I think is a space, how about like 10? I can come over here, clear my screen, compile, and run, and I don't know what that is. Something, maybe a tab, maybe? I don't know. All right, let's try something else, like 13 maybe. Damn it, what the heck? All right, well, it's gonna go a little higher. But anyways, if I wanted to know what all the characters were, a really cool trick you can do once we cover chapter 6 is you can just use a for loop, and we'll just say like int x is equal to 0 while x is less than, I don't know, we'll go up to 1,000, x plus plus, and I'll just say system out print line, and then I'll say x, that's the location, and what characters at that location would be char. I'll cast x to char. Yeah, I think it should work. So I'm going to save that and come over here, compile, and run. So man, maybe 1,000 was too much. Okay, so you see these. Here, let me stop this. Yeah. We'll just say 500 for now. All right. All right, so you see these question marks? They're coming by. I'll scroll up in a little bit. Okay, it's basically, it's just my computer doesn't have whatever character that is. All right, that's why there's just a bunch of characters. But I scroll up to the very beginning of this. Same thing with this character. I have no idea. One of them is actually like the noise, like what do you call it? Like the ding. I forgot which one it is, but one of them is. But you can see, dang it. Every time I try to use the arrows and it's like hopping down. Okay, anyways, you can see, so at 10 looks like it's actually like a new line or something, right? Because you have that space right there. It didn't really know what was at 13. Like, yeah, maybe some control characters. And then like right at 33 is the exclamation mark. And then we start getting to the symbols, right? This is where like, this is all ASCII character set, numbers, right? Letters, lowercase letters. And then once I get out of the ASCII character set, right, then I get all these question marks. But at some point, it might know something. It has to know something. Right, there's that at 62 or 162, there's like the cent sign. I don't know what you call that, but that's something, right? There's this eye looking thing. That symbol right there. Right, these chevrons that are off to the side. This A that's underlined. Right, there is all these Unicode characters there. Some of them my computer can translate, some of them they can't. But if you're curious, you can go to the back of your book, or you could just Google this, right? By just typing Unicode characters. And there's actually a website that will tell you like what number each one corresponds to. I thought it was like Unicode, Unicode.org. If you click here, I don't, well, it wants the hex number, but you can search for the actual character that you're looking for, and it'll tell you like what value it would be. Dang, all this is in hex though, so I don't know how useful this will be. But if you convert hex to like the numbers, then you'll be able to know what number it is inside of the Unicode character set, like what integer position. So like just take like 1E94, convert it to decimal. So you could just say like hex to decimal. We'll just use this converter, right, into the hex one. I'll say like 1E94, convert, and it's 7,828. Like that's what place that is in the Unicode character set. Like, you know, these characters here. Okay, and then you just use that number, and then you can just print it out. You can also pass hex values in, but you would have to know how to convert all that. It really isn't that difficult. You just have to know hex. But anyways, this for excuse me. The for loop is something we're going to cover later, like in chapter 6. So don't feel like you have to understand what's going on here. But I was just trying to show you like all the different type of characters that we can use. All right, I'm gonna hop back over here. The last one is Boolean. We're going to actually use this one a lot in chapters 5 and 6. It represents a true or false. Okay, and there's reserved words for it, true or false. So you cannot have any other value. It has to be a true or false. Other programming languages let you use like ones and zeros, but Java's pretty strict. It's just true or false. So inside of the character example, I'm just going to go ahead and give an example of Boolean. So you can declare a Boolean type. And I'll just say bool1, and I'll just, it's either a true I'm going to comment this out so that it's not printing a bunch of stuff. All right, hop over to the console, clear my screen. Oops, dang it. And you can see the bool, it's true, like it's going to print out true or false. It cannot be anything else, just two values. All right, and we are going to use that one actually quite a bit in chapters 5 and 6 to control loops and conditional statements. And that is it for the different data types. Okay, that was actually pretty quick. So there's 8 primitive data types. You have 4 for integers. I'm just going to review that really quick. You have 4 for integers, and you have 2 for floating points, 1 for a char, right, that we get from the Unicode character set, and then 1 for Boolean, which is a true or false value. All right, so I'm gonna go ahead and start talking about this really quick. I don't think I'll be able to cover it because I want to give you guys a quiz to do in class. Maybe I could cover all of it. All right, so let's hop back over here. All right, so expressions. An expression is a combination of one or more operators and operands. Arithmetic expressions compute numeric results and make use of arithmetic operators. So you have addition, subtraction, multiplication, division, and we have this remainder, which is like division, but just gives you whatever's left over. If either or both operands are floating point values, then the result is floating point. So Java does what it calls like whatever is the bigger data type, that's what the result is going to be. So if you're trying to store this into an integer and then you're using a float, then it's going to tell you you're going to have a loss of precision. So you're going to have to decide what type of data you actually want to use for these arithmetic operations. If both operands to the division operator are integers, the result is an integer. The fractional part is discarded. Okay, so 14 divided by 3 will give you 4. Like, it's not going to retain the fractional part. And then 8 divided by 12 will give you 0. It's not going to retain the fractional part. The remainder operator, percent, will return the remainder after dividing the two. So 14 divided by 3, but the percent gives you the remainder. It's telling you 2, right? Because 3 goes into 14 4 times, which is 12. So then if it only goes into, so it goes in evenly to 12, that means you have 2 left over, right? So 8 divided by 12. 12 does not go into 8 at all, so the remainder is 8. So quick check. So what are the results of the following expressions? 12 divided by 2 is this going to be 6, but 12 divided by, or 12.0, which is a double, divided by 2.0 is going to be 6.0. Okay, so here they're just telling you like the result is going to be integer. This one's going to be double. 10 divided by 4, the result of this is going to be an integer, but 10 divided by 4 is actually going to be 2 because in integers we do not retain the fractional part. All right, so 10 divided by 4.0, the result, because we're using a double in the 4, the result is actually going to retain the fractional part, but it's going to be a double. So the result of that is going to be 2.5. Yeah. And then 4 divided by 10, an integer. Integers do not retain the fractional part, so 10 does not go into 4 at all. So 4 divided by 10 is actually just 0. Where 4.0 divided by 10, because we're using 4.0, the result of that is going to be double. So we're actually going to see the fractional part of that, so it's going to be 0.4. And then we have 12 remainder 3. That means if we divide 12 by 3, what's the remainder? And the remainder of that is 0, right? So the result of that is just 0. We have 10, excuse me, 10 divided by 3. So 3 goes into 10 3 times, which is 9. The remainder of that would just be 1. And then we're trying to divide 3 by 10, but we're using the remainder. So the result of that is going to be just 3 because 10 did not go into 3 at all. Right? And here are the results. Integer resulted in 6. 12 divided by 2, same operation, or same numbers technically, but since we're using double, it retained, there's a 0.0 at the end. This next one's pretty interesting. 10 divided by 4, we completely lost the fractional part, where 10 divided by 4.0, we retained the fractional part, and we had 2.5. 4 divided by 10, both integers, so the result of that is 0. 4.0 divided by 10, the result of that is 0.4, because the 4 is a double, even though 10 is an integer. And then when we're doing the remainder math, 3 goes in 12 evenly, 0, the result of that 0. So 3 goes in at 10 3 times, but it's 3 times 3 is 9, so there's 1 remainder. So the result of that is 1. 10 does not go into 3 at all, so that means all of this 3 is left over. So the remainder is 3. Any questions on that? Okay, so it's just kind of important to know like what to expect from the result. So I'm going to kind of give you, let me just do a quick example on that. I'm going to go to new, file, save as. I'm going to call this one arithmetic, or no, decimal data type. I have no idea. I'll just go with arithmetic. With the way you spell it, that looks right. Arithmetic, save that, dot Java, save. All right, so what they're telling you is if I tell like an integer, num1, okay, and I said num1 is equal to 10 divided by 4. Okay, and then I said system.out.println. All right, put the result. Go over here, clear my screen. Dang it, what am I doing? All right, so let's go. All right, so there's my result 2, right? Because if I 10 by 4, 4 goes into 10 2 times, but it has a remainder of 2. But if I just say I came over here and I put like a 0.0 at the end, what do you think is going to happen? The result of that has a fraction. An integer cannot hold a fraction, right? But Java treats this like a 64-bit double. So what's going to happen is this whole operation is going to be a double that you're trying to force into an integer. Java is going to get mad at you, right? It's telling you incompatible types. You have a double. The result of that arithmetic is double, but you're trying to slap it into an int. So you can't actually do this into an integer. You can cast it or do something like that. If you actually really wanted to do it, then perhaps maybe you should come over here, make a new variable called double, and call this one 2, and then you can slap on that 0.0 at the end of it. All right, so now I want to hop over here, clear my screen, compile. All right. So that's the result of actually having that. Okay, now the interesting thing though is, even though I store the result into a double, like say I have num3, this is not going to give me, num3 is not going to be 2.5 because the result of the math is integers, right? I have an integer here and I have an integer here. This is integer math. Integer math discards the fractional part completely, even though I'm saving the result into a double. But Java did the math as int and int. Over here, we've made this one a double, so it did an int and a double. It made them both doubles when it did the math, so I was able to retain that value. But for num3, we're actually going to not have the fractional part, even though we're storing the data into a double. I'm gonna come over here and clear my screen. Right, and you can see that even though num3 is a double, because that math was done as integers, it did not retain the 0.5, right? Because that is integer math right there. The fractional part just completely got dropped off. Any questions on that? It's kind of important to know, like those are the concepts I'm going to test you on. Like I don't test you on the easy stuff. It's like truly seeing if you understand what's happening, what's Java doing and what data is being stored where. So keep that in mind. All right, so I'm gonna stop there and give you a quiz. Let's see. But I already gave you guys quiz 1 and quiz 2, but I have these old ones from, let me see what this one is. Oh, dang, what the heck? That was quiz 3? All right, yeah, this is a good one. We talked about using the scanner class last week. I know I haven't talked about it today, but you should remember stuff like that. I'm gonna go ahead and copy what I did here and hop over here, add a new, okay, this is gonna be quiz number 3. do tonight. All right, so what I want you to do is I want you to write a program that prompts the user for two floats. Okay, then calculate the sum difference in the product and quotient of each. Include the fraction. Well, you don't really need to do that because if you're using floats, it shouldn't matter. All right, and then print the results. Yeah, so you're basically just asking for two numbers, and then you're adding them, subtracting them, multiplying, and then finding, like dividing them. Pretty simple stuff. Okay, any questions on this? All right, so you should remember the stuff that we talked about last week. If you don't, then you're not reviewing enough. Okay. All right, let me save this and publish. There are examples of reading data in my Dropbox that I share with you guys, so you can look there if you need to look there. Let me see your work before you leave, so I can give you your grade. If you walk out of here without doing any work, you're going to get a 0. Okay. I want to see everybody's work before they leave.